Now we want to look at what's called the zero property. And in this investigation, it's going to be a little bit different. We're going to notice a pattern. So it says investigation. Notice the pattern of the powers of 2. So we have 2 to the 4th is 2 times 2 times 2 times 2. If you multiply that out, you get 16. 2 cubed is only 2 times 2 times 2. It has one less power of 2, so that's 2 to the 8th. 2 times 2, the next one, 2 squared, 2 times 2 is 4, which has one less power of 2. So notice we kind of keep dividing by 2 here, 16 divided by 2. And the reason we're dividing by 2 is because there is one less 2. So 2 times 2 is 2 to the 4th. 2 to the 1st is just 1, 2, so it's 2. So 2 to the 0 is actually, if we keep dividing by 2, so divided by 2, divided by 2, divided by 2. Following that pattern, we divide 2 by 2, and we get 1. So our rule here in words, any number to the 0 power, to the power of 0, is 1. In symbols, we could write x to the 0 is equal to 1. And that's for all real numbers. And so our examples here should be very simple. 221 to the 0 power, oh, well, that's 1. M to the 0 power, 1. All of this wonderful stuff in here, 31 times x cubed times y to the 4th times z, all of that raised to the 0 power, 1. And there you have it, the 0 power. Let's go ahead and look at the quotient property. This says expand c to the 12th over c to the 8th, then simplify. I chose a large number, so I have to write 12 c's here. 1, 2, 3. Divided by c to the 8th. So I put those in expanded form. Well, we learned back in pre-algebra, probably, that c divided by c is 1. So out of these 12 c's on top and 8 c's on the bottom, 1, 2, 3, 4, 5, 6, 7, 8 of those cancel to become 1, and we're simply left with these 4 c's left over. So we have c to the 4th. Well, what happened there? Or what did we do? 8 of the c's canceled, and so we're left with 4, which means we can take this upper number and subtract the lower number to get how many c's we have left. So to find the quotient, the rule, to find the quotient of powers with the same base, subtract the exponent of the denominator from the exponent of the numerator. So from the exponent of the numerator. In symbols, we have x to the a over x to the b is x to the a minus b, where x cannot equal 0. That's a little disclaimer there because you cannot divide by 0. So that's the rule, the quotient rule. And then a negative exponent property. Find c to the 8th over c to the 12th in 2 ways. Well, we can expand and then simplify. So we have 8 c's, 1, 2, 3, 4, 5, 6, 7, 8 over 12, 1, 2, 3, 10, 11, 12. And well, we can do the same thing. There's 8 of them on top. 1, 2, 3, 4, 5, 6, 7, 8 of those cancel. So what's left in the numerator? A 1 is left in the numerator. So this is 1 over c times c times c times c is c to the fourth. So there's our answer, 1 over c to the fourth. We could get that by simplifying. And then we could use the quotient rule. Well, the quotient rule tells us we should take the exponent of the numerator and subtract the exponent of the denominator, which gives us c to the negative 4. Now, the part that we want to investigate here is we took one problem, solved it 2 different ways. We did them completely correct. We didn't make any mistakes. We used the rules that we could use, and we got 2 different answers. But what does that tell us about our 2 different answers? Those 2 different answers have to be equal to each other. And so 1 over c to the fourth equals c to the negative 4. So what you can see there is if you have an exponent or a power in the denominator, you can move that base to the numerator because this is kind of like over 1. You can move it to the numerator, but you have to change the sign of the exponent. You must change the sign of the exponent. So here is the rule. It's not the clearest with this typing here zoomed in, but this is x to the negative exponent of a equals 1 over x to the a. So another thing, I said it one way, we can think of it the other way. If you have a negative exponent in the first part, you can move the whole thing. You can move the power to the denominator, and you now have x to a positive a. Also, while we're at it, using that, we can come up with something else and just makes it a little easier. This time we have a negative exponent in the denominator. Well, we use what we just learned. But 1 over x to the a, we remember dividing is the same as multiplying by the reciprocal. So this, I'm going to do a little extra step in here. This is 1 times, we're going to multiply by the reciprocal of this because dividing is the same as multiplying by the reciprocal, x to the a over 1. Well, that's 1 times x to the a over 1, which is x to the a. So if we have a negative, the big rule here is if we have a negative exponent in the denominator, the power can move to the numerator and you change the sign of the exponent. So if you're going to move the exponent around from the numerator to denominator, you change the sign of the exponent. Do not change the sign of the base. And the last rule here is the power of a quotient. This is going to be similar to the power of a product that we looked at in a previous one. And this is going to be write c to the, I think that's an 8, c to the 8th over d squared in semi-expanded form and simplify. So c to the 8th over d squared, the whole thing squared, is going to be multiplied by itself. Right? That's what squared means. And then we simplify. Well, this is c to the 8 plus 8 is 16, and this is d to the 2 plus 2, so 4. So really, kind of like the power of a product, this 2 can be multiplied times each exponent. So the exponents inside the parentheses can be multiplied by the exponent outside the parentheses. Here you see the rule in algebraic form. We didn't have any examples for these last 2, so I'm going to make one up here. Let's say we have 7 to the negative 2 power. Well, that's a negative, so what we see over here, we can put this as 1 over 7 to the positive 2 power, which, if you want to keep simplifying, that's 1 over 49. And another one, just to show you this, if we had x to the negative 2 times y squared over z to the negative 5, we have a few negative exponents in there. Well, a simple way to remember this is if you have a negative in the numerator, a negative exponent in the numerator, it can move to the denominator, but change the sign of the exponent. So we're going to change it to positive. So we took care of the x to the negative 2. We have this y squared here. Nothing happens with that because it's just a regular y squared. And then z to the negative 5th, that's a negative exponent in the denominator, so we can move that to the numerator and change the sign of the exponent.